Okay.
That's great. Now I've got quiet. And so we're going to look at equations of lines and planes in R cubed. And in some ways, this will feel like a review of something you might have done in pre-calculus, where you looked at graphs of lines, or maybe even calculus 1, where we looked at graphs of lines, maybe planes even sometimes. But this is going to be different because these graphs are lines in R cubed, not lines in the plane, although some of those concepts will be helpful for us. All right, well, the concept of slope is good enough for measuring how much a line is tilted in the plane in R squared, but that's not enough in space. We'll need to use a vector in R cubed to describe the tilt of a line. So the parametric equations for a line are as follows. X equals x1 plus some number a times t. Y equals some number y1 plus some number b times t. Z equals z1 plus some number z times t, where t is the parameter. This line goes through the point x1, y1, z1. In other words, this is kind of like synonymous with point slope. We have a line that is parallel to this vector a I plus b j plus ck, and it goes through this point. It's kind of like this is the slope, this is the point it goes through. But anyway, you have to then go to parametric equations to find its equation in parametric equations. So x1 plus a t, y equals y1 plus bt, z equals z1 plus ct, for t the parameter. Okay. So we're going to try this one. You have to think hard through this one. Give the equation of the line perpendicular to the plane spanned by the vectors 2i minus 3j plus k and I minus j, and passing through the point 1, 0, negative 5. Now, do you see the problem? We need this line to be perpendicular to the plane spanned by these two vectors. How could we find a vector that's perpendicular to the plane spanned by two other vectors? And I hope you would say automatically, why, we would find the cross product, which would be perpendicular to both of the other two vectors. And the answer is yes, that's exactly what we need to do. So, finding the cross product, I, j, k in the top row, 2, negative 3, 1 from here in the second row, and 1, negative 1, 0 in the third row. And, well, okay, we'll do it the long way. I times this minor, which is 0 minus negative 1, so 0 plus 1, so 1i, minus j times 2 minus 1, so it's minus j times negative 1, which is like plus j. I don't know why my software put these in the opposite order, but I guess that it won't matter. And then negative 2 plus 3k, so plus k, so I plus j plus k. And we have our A, B, and C each equal to 1. And passing through the point x is 1, y is 0, z is negative 5. And so we can say 1 from this point, plus 1 times t, 1 coming from this 1i, plus 0, or sorry, y equals 0 plus this 1 times t, and z equals negative 5 plus this 1 times t. And that is the parametric equations of the line that's perpendicular to the plane spanned by these two vectors and passes through this point. So now that we know how to do that, we could take each of these three equations and solve it for t. Actually, in this case, it's going to be pretty easy to do. For this one, t equals x minus 1. For this one, t equals y. And for this one, t equals z plus 5. And if you set those equal to each other, then that is called the symmetric form, or the three-sided equation for a line in three-dimensional space. So, of course, solving this equation for t, you get x minus x1 over a. Solve this one for t, you get y minus y1 over b. Solve this one for t, you get z minus z1 over c. And that's called the symmetric form for the equation of a line. This one, it would be, let me see, x minus 1 equals y equals z plus 5. We didn't have to divide by anything other than 1, so that kind of made that one easy. So, here's another example. I'll wait for the next video and do the other example.